Assalamualaikum warahmatullahi wabarakatuh. Today we will continue on our topic about SFEE devices. Now we are try to solve the example of turbine for steam. Okay, so this is the turbine. Okay, this is the schematic diagram of the turbine, and you can see here that the turbine will produce work that we call it as a W dot out or power output, and it produces about 5 megawatt. And this is the properties at the inlet of turbine, and this is the properties at the outlet of the turbine. Okay, so the question is, what is the enthalpy between between state 1 and state 2, as well as kinetic energy and potential energy. So please have a look at the unit, and the unit is in kilojoule per kg, which means all the properties must be in small letter. Alright, so since this is about steam, we have to be very careful. Okay, we have to check the phase at each state. Okay, for example, at state 1, we have a pressure of 2 megapascal, temperature of 400 degrees Celsius with a velocity of 50 meter per second, and the elevation is 10 meter. Okay, so the intensive property here is P and T. So you have choices to sketch TV diagram or PV diagram. So in my case, I sketch TV diagram. Okay, and the constant pressure is 2000 kPa. I convert MPa to kPa. So I look at table A5 and I find out that T saturated is about 233 degrees Celsius. Given here, temperature is 400 degrees Celsius, which means the given temperature is greater than T saturated, so we know that the state is in superheated. So if the steam is in superheated, then we have to refer at table A6. At table A6, we look at pressure of 2 megapascal and temperature of 400, and I get H1 as this number and specific volume as this number. Okay, for state 2, this is the state 2 at the exit. If we can see all the properties here, the pressure is given as 15 kilopascal. So you can see that the function of the turbine is to reduce or to decrease the pressure. Okay, so what happened to the state? Okay, so we can see here, this is quality. So the quality gives us a clue that the phase is in saturated mixture. Alright, and the velocity is 180 meter per second and the elevation is 6 meter. So we have to check the phase. But as I said, if X is given, then we know that this phase is saturated mixture. How to find H2 and V2 if the phase is saturated mixture? Okay, we use a special formula. What is special formula? If you still remember in chapter 2, okay, we use formula Y is equal to YF plus X YFG, okay, and Y can be H, specific volume, internal energy, and entropy. Okay, so that is why I called this formula as a special formula. So if we want to find H2, if the phase is saturated mixture, then I use this special formula and I change Y with H. Okay, so H2, and I look at table A5, okay, at 15 kilopascal, and I get all this value, and I get H2 as 2361.01 kilojoule per kg. and specific volume as 9.0181. The same procedure as H1, just we change H to specific volume. So the question is, what is delta H? So delta H, H2 minus H1, then we get here 2361.01 minus 3248.4, then we get the value as a minus 887.39 kilojoule per kilogram. Next is delta KE, which is kinetic energy, C2 square minus C1 square over 2000. So C2 here is 180 square minus 50 meters square over 2000, and I get as 14.95, and my unit is kilojoule per kg. Next is potential energy, the changes of potential energy. Don't forget G, Z2 minus Z1 divided with 1000, and I get I put it G as 10. You can also put G as 9.81, either one. Okay, so Z2 is 6 minus 10 over 1000, and I get minus 0.04 kilojoule per kilogram. Okay.